Hello everyone. From now on we will have our lessons virtually like this. I will post one or two lessons every week on the YouTube, and I will ask you to watch the videos, the lessons over there, just like we do in class. Instead of teaching on board, I will teach you here through online, and I will upload them every Sunday for the next week. All right. So this week we'll do 7-4, but before that, let's see how I want you to follow the lessons. As you know, before the spring break, we had 3 lessons of this unit, exponential functions. Now we are on the 4th one. On the first 3 lessons, we mostly talked about the properties of exponential functions, how to do operations with them, how to do them algebraically, how to graph them, asymptotes, x-intercepts, y-intercepts, domain and range, and behavior. These are more analytical and algebraic things we do in the first 3 lessons. But on the lesson 4, it's gonna be more talking about sequence and series. This is something definitely different unit, but it's kind of related to exponential functions. And so then we will talk about the geometry sequence in this unit too. You may hear from the news all the time the exponential growth on the things happening nowadays. The other way to say it's geometric geometric increase. So it's the same thing. That's why we have geometric sequence in this unit too. Alright, so we'll talk about them. First, what does a sequence mean, and the series. We'll talk about them. So basically, let's start with the definition. A sequence, as you see, is a function in which the domain consists of natural numbers and the range consists of real numbers, it says. By the way, I forgot to tell you, this lesson is gonna be on page 379. So make sure you have your book in front of you, open the correct page, and take notes as necessary. Okay, so it's just like in school, you have your book in front of you, and I will have everything over here, and I will ask you to write them down. Okay, so let's get started. This is again on page 379. Alright, so page 379, the definition of the sequence is that a sequence is a function in which the domain consists of natural numbers and the range consists of real numbers. It's like that. Let's say we have some numbers like a 2, like a 4, like an 8, a 16, 32, and maybe more, right? I can tell the first term is 2, the second term is 4, the third term is 8, the fourth one is 16, and the last one, the fifth one, is 32. So a sequence is, if you can see a pattern between the numbers, a constant term is added or multiplied all the time, something like that, you call it a sequence. So as you can see here, in this question we multiply the previous number by a 2 all the time. So we multiply the 2 by 2, we get a 4. We multiply the 4 by 2, we got an 8. Then we got a 16, and we got a 32. So if you catch something like that, this is called a sequence. Alright, this is the deal. This will be a sequence then. Okay, so we show them like that mostly. The first term is 2, right? We are given here, that's 2. Or the second term is a 4, or the third term is an 8. The fourth term is a 16. The fifth term is 32. It might be more, of course. It might be even infinite numbers of terms here like that. But whenever you see something like that, a1 is equal to 2, that means the first term is equal to 2, the second term is equal to 4, and so on. So if we go back to the domain and range, domain will be the numbers, the order numbers that you have, the first, second, third, fourth, fifth. That's part of domain. And the answer you have, like you see the 2, the 4, the 8, 16, 32, they will be the part of range. That's the deal. Alright, so 1 is here is in the first one, for example, 1 is the domain, 2 is the range. Here, 2 is the domain, 4 is the range. 3 is the domain, 8 is the range, and so on. That's the idea of the sequence. Alright, so let's turn the page and start with the very first example. It says determine whether the sequence 2, 6, 15, 30 is a geometric sequence or not, or even it's a sequence or not. Alright, so as we said, it's gonna be a geometric sequence when you realize the pattern, there is a common number that you multiply the previous number by that. For example, 2 to 6, 6 to 15, 15 to 30. If you are gonna go increase like that, you should have a same number for between them. Look at that. 2 to 6. If you multiply 2 by a 3, that's a 6. If you multiply 6 by what makes 15? It's like a number decimal, I guess, right? Or if you multiply 15 by what, it makes 30. That's definitely a 2, right? So basically all these numbers must be same. So you multiply 2 by 3, that's a 6. But when you multiply 6 by 3, that's actually an 18, not a 15, but looks like we have a 15 here. Or when you multiply 15 by a 3, it's supposed to be a 45, not a 30. So you see, we don't have a solid pattern here. So we don't say this is not a geometric sequence. This is not a geometric sequence. Like that. So in order to say it's geometric, you should multiply each previous term by the same number all the time, like a 3 here all the time. But it looks like we couldn't do it. Alright, so not a sequence at all. Here's the first question. Let's look at the second one. It says, find and graph the 6 terms of the geometric sequence. And later on, I put graph again here. Later on, state the domain and range. That's the thing. So first thing is that find the first 6 terms. Okay, let's write them here. -1 is the first number, as you can see. -2 is the second. -4. So see if we have a pattern or not. -1 times 2 is a -2, right? And -2 times 2 is -4. So it looks like we have a pattern here. Let's multiply the -4 by 2. -8 then. Let's multiply the new number by a 2. That's gonna be a -16, right? So it says 6, right? 6 terms here. So we have 1, 2, 3, 4, 5, and 6. When you multiply -16 by 2, that's a -32. So we got all those numbers. So basically, we have those 2's right here. We call them R. That's the new term. R means the common ratio. Each time you multiply the previous number by is called the common ratio. So we can find it like that. If you divide 2 consecutive numbers by each other, it must be equal to that all the time. Look at the -2 and -1. It must be equal to the -4 and -2. And it must be equal to -8 to -4. It must be -16 divided by -8. And last one, -32 divided by -16. That's true. It's 2 all the time. If you realize one of them is not given a 2, then just like in the previous question, you will just say, no, it's not a geometric sequence at all. Alright, so this is good. This is a geometric sequence, and we find the other 3 numbers. They are -8, -16, and -32. If we're gonna graph them here, you know, when you consider the first term, let me put them here on top, the number of terms. You know how this was A1, right? Stands for the first term, second term, the third, the fourth, fifth, and sixth, right? Okay, so look at here on the graph. 1, 2, 3, 4, 5, 6, 7, 8 on the x-axis represents those the first 6 terms, right? Since A1 is -1, we got a -1 here, and we will have a dot right over here. The second term is equal to a -2 somewhere here. The third term is equal to -4, so here. And the fourth term is a -8, and it goes down right over here. It's like that. You see, when you put this all together, it's exponential, just like we learned in the previous lessons. We will have kind of a line passing through here like this way, right? So another way to say exponential is geometric, which is true for geometric sequence as well. So this is the graph. So if we go to the last part of the question, the domain, just like the definition that we discussed, you know how we have 6 terms? Then 1, 2, 3, 4, 5, and 6 are the part of domain. But just those numbers. you know what, you will never have a like 1.5 in the domain, because they must be like counting numbers 1 2 3 4 5 6, you know, because you say fifth term, right? You don't say 5.5 term, something like that. So they will be just numbers. And the range are the numbers that you got. You know how we have a sequence as -1, starting with -1, -2, -4, -8, -16, and -32. This is the range then. Okay, that's the idea, domain and range. Alright, so this is the second question. If you need to go back, by the way, just stop the video, rewatch the part again, and if you will have questions, you know what to do, just put your question on the private comments or in the general one. I will get back to you as soon as possible. Okay, let's see a word problem. As you can see the word icon over there on the corner, that's a word problem. Javier wants to eat less chocolate each day. To achieve this, he decides to start with a 50-gram bar of chocolate and eat half of it in the first day. Then the half of the leftovers of the bar on the second day, and the half of that the third day, and so on. So it looks like he's eating half and half each day. If Javier starts on a Monday, what's the mass of the peas that he will eat on Friday? So how much he's eating on Friday is the question. So basically, you know, right? Let's put the dates. Monday, Tuesday, Wednesday, Thursday, Friday. Looks like we need first, second, third, fourth, and the fifth. We will have a sequence with 5 terms, right? We start at 50. Okay, so he starts on a Monday. He starts with a 50-gram of bar of chocolate and eat half of it in the first day. So we start with a 50, right? So looks like since we are starting with 50 and we are gonna eat the half of it the first day, he will eat just half of 50. That is a 25. Okay, next day, Tuesday, right? He eats the 25-gram already, and there's a 25-gram left. Half of that leftover is gonna be a 12.5. And Wednesday, 6.25, because the half of the other one. And the other day, if you divide 6.25, we will get a 3.375. He eats 3.375 grams of the chocolate on Thursday, and the Friday half of this one, I think it's 1.6875. So this is the amount that he is eating on Friday. Okay, so basically this will be our answer. He is eating this much. You see, you can find the answers of the sequence questions by just basic math, because these are word problems and real life applicable, you know, so we can even handle them without doing like that much math. But if you are gonna use some technique, you can say A1 is 25, stands for that he eats 25 grams. Second day, 12.5. The third day, 6.25. The fourth day, 3.375. And the Friday, he eats 1.6875 grams. Okay, so this is the idea. Let's go more on like a formula of the pattern. You know how we are given some numbers and it keeps going like that, and what formula represents the situation. Okay, all right, so we call this one is like, actually it's gonna be in the next slide. I think I should have had it here too. We will talk about something this called explicit form, right? So we call it as like an is equal to a1, the first term, times r to the power n minus 1, which means what? You know how we have a sequence, for example, in the first question, -1, 3, -9, 27, and it keeps going, and we want to catch a pattern. Instead of writing this all out, we want a formula, just like in functions. So that thing is called explicit form. What represents this infinite sequence is called explicit form. That's the idea, right? So, for example, start with this question. We have the formula again one more time. an is equal to a1 times r to the power n minus 1. An is the common term, a1 is the first term, r is the common ratio, and n is again the nth term of that. Okay? So, to find the general formula, looks like we need to know the first term and the r. A1 and R are the ones that I need to know, right? If you go back to question, we start at -1, it becomes at 3. Let me write them here. -1, 3, -9, 27. Each time I multiply it by a -3 to get the next term, isn't it? Because -1 times -3 is at 3. 3 times -3 is -9. And -9 times -3 is 27. Looks like R, the common ratio, is -3. And you know that, right? The first term is the first number, that's -1, right? So if you want to write the general formula, that will be an is equal to a1, which is -1, right, times R. R is the common ratio, that's a -3. -3 to the power n minus 1. Be careful, this is always n minus 1 for a reason. Not n, but n minus 1. Okay, so this will be our formula. Let's look at the other question. This time, if you look at the question here, we are given the 8th term, not a sequence, like part of the sequence at all. And we know the common ratio, right? Looks like from a8 we have to go back to a1, because if you remember the formula, I need to know the a1, I need to know the common ratio. We are luckily given the common ratio, but not the very first term. Then we will just make a little experiment to do that. a3, a4, a5, a6, a7, a8. So a8 is 5, but I need to reach the a1 right here. You see, each time we multiplied the previous number by a 1/2, and we get the half of it, right? So looks like, since it is divided already, I have to go backwards and multiply it by 2. So, because go backwards, 5 times 2 is 10. So 10 becomes a 20 here, 40, 80, 160, because each time I multiply by a 2, 320, and 640 here, right? Because the common ratio is 1/2. If you go it the normal way, from a1 through the a8, 640 multiplied by 1/2 gets a 320. 320 multiplied by 1/2 gets a 160, and so on, until we get a 5. So looks like this way we can get the a1 as a 640. So that's the thing. If you look at the book on page 385, where the example 4 is, they do a different way. That's also fine. They just plug the 8 into that and they set that equal to 5. That's another way to find the a1, the very first term. Or instead, you can just make a little experiment to find the very first term. Because if we are looking for the formula, we need to know a1 and r. R is given. a1 is, no matter how you find, that's fine. Either how it explains in the book, or just like do it backwards to get the very first number. So after doing that, to find the formula is very easy. Remember, it starts with the first number, 640 times r. R is the common ratio, that's a 1/2. So make sure you cover the 1/2 with parentheses and write an n minus 1 on top. So this is gonna be the explicit form of the function. So whenever it says find the nth term or find the explicit form, they are same. You just do this way, okay? And we will continue with example 5 very soon. Okay, question 5 right now. Question 5 is on page 382. Given a formula for a geometric sequence in recursive or explicit form, translate it to the other form. So in this case, now in geometric sequences, we have two ways to represent the sequence. Remember the previous question, we talk about the explicit forms that we can write a formula for the given sequence. Instead of writing all the terms out all the time, we can write an explicit form. It was, remember, an, any term, n represents the nth term, that means any term, is equal to r, the common ratio, times the a times n minus 1. So basically this is going to be the recursive form. So it looks like it is switched here, but I meant this is the recursive form. The an is equal to r times an minus 1. It's basically the nth term is equal to the common ratio times the previous term. And explicit form is actually this way. An is equal to a1 times r to the power n minus 1, which means the first term, an, is equal to the first term times the common ratio to the power n minus 1. So one more time, these two should be switched. Explicit form is an is equal to a1 times r to the power n minus 1, whereas the recursive form is just an is equal to r times an minus 1. So the difference between them is that explicit form is more explicit. It's just like the general formula, like a function, but recursive is relating the nth term to the previous one, or any term to the previous term. That's the recursive form. Okay, so when we look at the questions here, the first question, it says a1 is equal to 5, the first term is 5, and the nth term can be written as 1 over 5 times an minus 1. So I can tell this is given already in the recursive form. Recursive form. How can I know that? Because when we look at the recursive form formula, it's an is equal to r times an minus 1, and here we have an and an minus 1. So this is the recursive form. We are relating the previous term to the next term. So it looks like we will write this one in the explicit form. The question is asking what is the explicit form in question 5a. This is the question. So look at the explicit form. For this, we just write the nth term. We want the first term times the common ratio to the power n minus 1. So it looks like we are given the first term. So the first term here is just a 5. And the common ratio, if you look at the recursive form, the 1 over 5 that you can see here can tell you what is r, because an is equal to r times an minus 1, right? So the r here can directly tell you the common ratio. That's basically 1 over 5, right? So I can tell then the explicit form will be 5 times, which is the first term, times 1 over 5, which is the common ratio, to the power n minus 1. This is the explicit form. Explicit form. Okay, so this is the deal. This is 5a. Okay, so I'm going to erase this one now to do the 5b. Okay, so 5b. This time I can tell we are given the explicit form, right? Because it's exactly in this form. An is equal to a1 times r to the power n minus 1, where a1 is the 2 over 3 if you just compare, and the r is just 7, right? So we want to write this one in the recursive form. Remember the recursive form? Recursive form was this one. An is equal to r times an minus 1, right? So this is what we want. So still start with an. R is the common ratio that we said, that's a 7 here. So it will be just 7 and an minus 1. So to be honest, to write the recursive form, you just need to know what's r, because an and an minus 1 will be here all the time. That means you're relating to any term to the next term. It's just like the second term is 7 times more than the first term. That's the meaning. Or the fifth term is 7 times more than the fourth term. 11th term is 7 times more than the 10th term. That's the idea. Okay, so that's the deal. To find the explicit form, we want the first number, first term, and the r. To find the recursive form, we just need the r. That's the deal. Okay, example 6. Example 6 is asking find the 4 geometric means between 243 and 32. Before we talk about the before we find the geometric mean of the numbers, we need to know what's geometric mean first. Geometric means are the terms between two non-consecutive terms of a geometric sequence. Looks like 243 and 32 are just two numbers of the sequence, and we are looking for the ones in the middle. Okay, so looks like we will have 4 of them. So if you write it, 243 looks like is the first one, and the 32 is the last one, and we will have 1, 2, 3, and 4 between them. Okay, so remember the common ratio between them will be the same all the time. That's called r. We multiply the 243 by r, we got this new one. Then we multiply it by a new r, we got a new one. We multiply it by another r, we got the next one. It's just like this is the first term, a1. When we multiply it by r, we got an a2. When we multiply it by another r, this a3, a4, a5, which is we have now 4 terms in the middle. And when we multiply it one more time to get the 6th term, that's 32. So somehow we should relate the 243 to 32 to find the r, and so that we can find those a2, a3, a4, and a5. So here's the deal. 243. If I multiply this by r 1, 2, 3, 4, and 5 times, like r to the power 5, because we have 5 common ratios here, the result will be at 32. Yes, the number is getting smaller. That is 243. Now 32 looks like we have a decimal or a fractional r here. So we will find r, and when we find r, we will be able to locate all the other numbers. So basically, divide both sides by 243, like this way, and the 243 is cancels. So r to the power 5. I can tell 32 is 2 to the power 5. I can tell 243 is 3 to the power 5. They will always give you good numbers, guys, don't worry. So 32 is just 2 to the power 5, 243 is 3 to the power 5. That gets you one single r. If you take the 5th root of both sides, it will be just a 2 over 3. Looks like the common ratio here we got here is always a 2 over 3. Let's change the color and use a different one. 2 over 3. Each time we multiply by 2 over 3, we get the new one. That's the deal. Okay, so let's do. I will write the a2 here. I multiply 243 by 2 over 3. 243 is the first term, remember. 243 will be multiplied by a 2 over 3. That's gonna be get the second term. If you do the math here, 243 times 2 over 3, that's a 162. So for the a3, we will multiply 162 by another 2 over 3. Remember, 2 over 3 is the common ratio. That gets you a 108. That's the second number we are looking for. A4, the fourth term of the sequence, this time 108 times 2 over 3. Which is, if you do the math, you will see it's a 72, and the last one, a5, 72 times 2 over 3, that should be a 48. So these four numbers are the numbers between 243 and 32. So geometric means of 243 and 32 are 162, 108, 72 and 48. Four numbers. Alright, so that was the first objective of the lesson. That was first, what's that sequence mean? What's explicit form, recursive form, how do you find a geometric sequence, how do you define it's a geometric or not. We discussed these all. Now it's time to talk about series. That is on page 383, guys. So series is just a part of sequence, but series is the sum. So a series is the sum of the terms in a sequence. So for example, you know how we said 2, 4, 8, 16, 32, right? These are the terms of the sequence. 2 is the part of the sequence. 4 is the part of the sequence. But if this time we are looking for the sum of the first 5 terms, sum of the first 7 terms, sum of these specific terms, that's going to be called a series. So a series is the sum of the terms in a sequence. That's the deal. And we show it with Sn, stands for the sum. You know how we say an? That's for the sequence, right? The nth term of the sequence. And if it says Sn, that means the sum of the first n terms. Like S5, right? That means sum of the first 5 terms of the sequence. Like A1 plus A2 plus A3 plus A4 plus A5. So instead of writing that all the time, we just write an Sn, S5, S7. So to find the sum of a series, a sequence of a geometric sequence, we have two formulas. So you know how we have A1, R, and N, right? A1 is the first term, R is the common ratio, N is represents the any term. Same here. So if we are given A1, R, and N, let's say the first formula type, and we are looking for the sum of the terms, we have formula. It says A1 minus A1 times R to the power N over 1 minus R. R has to be other than 1. This is something else, not related to geometric sequence at all. Or if you are given again A1, R, looks like we have to know what's A1 and R all the time. But instead of N, but AN, the nth term, similar, but A1 minus AN times R over 1 minus R is going to give you the sum of the terms. Sometimes it will be easier to just calculate the sum by doing basic math, like sequences 1, 2, 4, 8, 16, right? What is the sum of the first 5 terms? It's easy, you will just add the numbers, right? To get that, that's okay, just do that way. But if it's like a long one, if it says what is the sum of the first 50 terms, first 30 terms, whatever, like you cannot write this all out and add them all the time, right? So then we are going to use the formulas. So basically you will see this one more, the first one. And you will just put them in the formula, that's it. This lesson is a bunch of formulas basically, okay? Shouldn't be a big deal for you. Okay, let's continue with example 7. By the way, we skipped that thing, this thing here. This is called sigma. This means sum of terms. We are not going to talk about this one. This is like a different concept totally. It's about this lesson too, but we're not going to discuss it. We have to spare a totally different lesson for this one. So basically I will skip the things about the symbol, the sigma. If you see a question like that in the exercises set, you can basically skip it too. We will not discuss this. We're just going to focus on the core idea of the geometric series and the sequence. So we will not talk about these kind of things, guys. Okay? So that's why I skipped the part over there, and we'll just look at example 7. So automatically this eliminates question 9. We will not do that. We will just focus on 7 and 8. That's it. Alright, so let's look at this word problem. It says Katerina wants to set up some dominoes so she can knock over one, which knocks over 2 more, each of which knocks over 2 more, and so on. If she wants to make 6 rows of dominoes, how many will she need in total? It's just like the coronavirus that we have right now, right guys? It's like, you know, one patient, one sick person, this affects the two other. Each of the two other affects new two patients, and it, you know, increases exponentially. It increases geometrically, right? So this is the same idea here actually. So it looks like you have a tile. That tile knocks down two new one. The two new one knocks another two, that makes a 4. Each makes a 2, that makes 4. Each of these 4 tiles are gonna knock 2 other tiles. That's gonna get you 8. Since it's a 6 rows, first, second, third, fourth, fifth, and the 6th row. In the 6th row we will have 32 tiles. Okay, so it's asking how many tiles, how many dominoes will be there in this case. So basically we can handle this question with basic math. You know, the first one is 1, the second one is 2, 4, 8, 16, 32. You will just add these numbers this way. 1, 2, 4, 8, 16, and 30. This is the first way. We can consider this one as the first way. As I said, if the numbers are easy, just add them up. When you will do that, you will see as 63 as the answer. Looks like we have 63 dominoes here. But let's see, we are using the formula here. Okay, I'm gonna call it the second way with the red color. Second way. Okay, we will mostly use this formula here. So since I have 6 rows, I will say n is 6. S6 is like a1 minus, which is the first term, minus a1 times r over 1 minus r. Of course there is an n here, that's a 6, as we said, S6. Okay, so here we have to convert this one to the situation, the formula here. A1 is the first domino, right? Can I say it is 1? Because that is the first tile, first domino. Yes, so we will have a 1 here. Minus, again a1, that's 1 here again. Times r. You see each time we multiply it by 2. Right? All the time it goes by 2. Right? 2 here. So I can tell the r, which is the common ratio, is a 2. So it's going to be a 2 to the power 6. Over 1 minus r. R is a 2 here. Okay, let me write them here also. A1, as we can see from the situation for the first tile, that's 1. And r, since it's doubling all the time, that's a 2. Okay, if you do the math here, that's a 1 minus 64 over 1 minus 2. That also gets you a 63 as the answer. Okay, doesn't matter which way you will follow. If you want to convert the situation to a word problem, to like a simpler way, an elementary way, that's fine. But again, if it's asking more terms like what is the sum of the first 20 rows, it's hard to do this all the time, like writing aloud. Maybe we should switch the formula. It's your call. Alright, this was on question 383. And let's continue with our very last question for today. As I said, question 9 will not be done, since we are not talking about sigma notation. Let's see what it is. Find A1. Looks like we are looking for A1 in a geometric sequence where the sum is 21.3125. Looks like n is 5. That means the first 5 terms, because S5, Sn becomes S5 here in this case. Looks like the sum of the first 5 terms will be 21 point something, where the common ratio is 1 over 2. So it's like actually a backwards question, since we are given r. Let me write them here. Given, we are given r, we are given Sn, we are given n, and we are looking for A1. Let's see which one this is gonna best fit. So we have r here in the first formula, we have n, we have Sn. So we can definitely use this one. The only difference with this first formula and the second one, that's an, but we are not given any an, so that's better to use the first formula here. We know what's Sn, we know what's R, we know what's N. We are just looking for A1. Okay, so let's get started. Sn 21.3125 is equal to A1. We don't know that. A1 minus, let me write that again. A1 minus again A1 because of the formula times R. R is given. As you can see, it is 1 over 2. So 1 over 2 to the power n here. N was also given, that's a 5. Over 1 minus R, 1 minus 1 over 2, that's it. So basically we just plug all this into the formula, the first formula here. First formula. We'll just do the math, that's it. 21.3125 and the bottom, if you do the bottom denominator, you will get a 1 over 2. On top it's like this, A1 minus, if you take to the 5th power of 1 over 2, that's a 1 over 32 A1. I just switched them, I put 1 over 32 in the front. That's equal to, if you fix the top, that's gonna get you a 31 over 32 A1. Okay, is equal to again 21.3125. Okay, alright, so now we will do this one. It's like division of two fractions, right? Remember how we do that. The top goes together like 31 and 2, and the ones in the middle, 32 and 1, they go together. If you do that, you will just get a 31 times 2 over 32 times 1. That's just 32. I skipped the 1 then. A1 is equal to 21.3125. Okay, so just multiply the both sides by the reciprocal of this fraction, like at 32 here, over 31 times 2. Same here, 32 over 31 times 2. This will all cancel. That was the point. And if you do the math, if you multiply 21.3125 by 32 over 31 times 2, you will definitely get this result. A1, which is the first term, that's gonna come up with an 11. 11 will be our answer then. Okay, so the first term is just 11. That's the case. Alright, this concludes our lesson. We did examples 1 through 8. Before that we discussed what's a sequence, what's a geometric sequence, what's a geometric series, what's explicit form, recursive form. So I want you to go over this lesson again of pages 379 through 384 and fill the gaps, take notes of this lecture, stop and watch it again, and do the exercise question. I also uploaded them on the Google Classroom. I want you to work on exercises on page 385, 386 and 387. So page 385, 386, 387. If you look at the first 50 questions, I want you to do the odd numbered questions on page 385, 386, 387. In the first 50 questions, do the odd number questions, okay? I also want you to check the answers in the back. When you do a question, check the answer in the back to verify it's good or not, okay? So you know how to upload them on the Google Classroom with your work shown on the paper. That will be better. And again, if you will have any questions, you know what to do. Just send a message through Google Classroom just tell me, Mr. I couldn't do this question, page 385, question 17. I will just help you with that, okay? But please take an action on your own learning. We have to do it remote, maybe like the entire semester from now on, so who knows. So if you will have questions, always try to get help, okay? All right, take care everybody. I will see you next time.